In order for these guys to be parallel, these two would have to be congruent, wouldn't they?
Yeah.
What's the ordered pair relationship when they're in the same spot in the same position of the line? What's that? No, they're corresponding. Those are corresponding. The consecutive ones are going to be consecutive interior, the ones that are same side inside, next to each other between the lines. Top left, that's what we call corresponding. Or top right, so on. Which meant you'd have to set them equal to each other. Pretty quick and painless, you've got your variables on both sides of the equation. Pick on the little guy, move stuff around. So you subtract the 5x, subtract the 13 at the same time, and hopefully you get 5 for x. Okay? And that's basically what you were doing for all of us. Okay? So hopefully it wasn't terrible. In all honesty, if you didn't even see the instructions on that, if you just saw it going, oh, this is going to solve for x, and you remembered what angle pair you were working with, it should have been pretty quick and painless. Were there other questions on any of those that you wanted to double check them real quick? Yes, sir. The 2 pages, both sides, yes, because it's scrolled through. Okay. All right. Oops, sorry. Yeah, that's.
The day you were here.
What's that? From Tuesday, yeah. But obviously, that was the Tuesday stuff.
Wait, are you going to keep them?
I did them. Yes, I was going to. I hadn't gotten to that yet because I wasn't here. We wound up getting tickets to the Cubs game on Tuesday. Drove down there and they canceled it because of the rain, which everybody knew was going to happen. They still had everybody drive down there. And then we had to turn around and had to take another half day yesterday. Shucks, and miss out on a meeting in the afternoon. I got over it. You can't do that while you're in class. You gotta do it for Sorry. So on Friday, the actual real Friday of last week, we did this sheet. That 3.2 one, where it had some pictures of things and stuff. Remember that? Okay. This was to be collected on Tuesday, which was our next Friday/Monday of this week, because we had no school on Monday, and then you basically had a day off on Wednesday, and you have another Thursday, which is kind of like a Friday, Monday today. This week sucks, ladies and gentlemen. This week sucks. So there should be a sheet that looks like this that you guys had from last Friday. You've got it. It says 3.2. B, on the other side says B and A. Alright? Now, guys, this one was basically the exact same thing as this, but it just told you that they were parallel, solve for x type of thing. Please make sure your names are on this and set that up. Okay? Okay? That's the one that looked like. Guys, we have a lot to talk about here. Remember, it looked like this on the front page. Okay? It looked like that. Here's that. We'll try to do this in some sort of an order here, guys. Excuse me. Yeah. This one, okay. Cool. And I put yours in the high. Alright. Oh, it's late. Oh, cool. Alright. The one from Tuesday, I apologize for all the weirdness of the weeks. was online.
Oh.
It was posted on the calendar. Okay. This stuff, guys, the stuff that you did on Tuesday that was hard to hear the volume and whatnot had this accompanying worksheet. It was posted online. I did not make copies of it so that way you can just basically go through the algebra. This was assigned to you Tuesday. All right? Any questions?
No.
Okay. Make sure your name is on that one and send that one up. Again, guys, again, this one was set up just for you to do it on paper. You didn't need a diagram for these things. All right? Then we'll talk. Yes, ma'am. Now, obviously, I know that the volume stuff was messed up, and that's why I was saying that it's the same thing in reverse. So your phone is like a describe things, you don't have to worry about looking at it anymore. If by chance you had a heck of a time trying to figure out what that meant, remember, guys, it was just the same things working in reverse. If by chance this was something that you did not completely fully understand, or for the one reprieve of I know that the volume was crap, you have Monday, I will take it. It's the only time I will do that. Let's do it again. Today,
I thought you were going to write finally.
as of right now, it looks like this shall not be an issue whatsoever. To get a quiz for the first half of the chapter by next Wednesday. What happens after Wednesday then is that it switches back to everything you did, I don't know, second quarter-ish of your Algebra 1 classes last year. It goes back to writing equations of lines, slopes, point-slope form, slope-intercept form, graphs, parallel lines, perpendicular lines, and so on and so on. But if we talk about it more in terms of geometry and its context, there is a lot of algebra. This was something you did poorly upon. You're going to hate it, and you're going to need to work your butts off because, unfortunately, one of the mainstays of all math classes that we always talk about writing equations of lines and how they work with one another, because we do it in algebra, reintroduce it in geometry, we do it again second semester in geometry. Algebra 2, we talk about functions and lines, input, outputs, about all the different types of stuff. Where they're linear, quadratic, quartic, all these things, logarithmic, exponential, conic, everything. Conics aren't always functions, but there are many graphs and lines and equations and things of the algebra. But it all comes back, okay? I want to say full circle, but I think that would be overstepping bounds on that. From what I've understood through today, even working with second hour, is that the few things that we talked about today really aren't earth-shattering. So in 3.5, we're going to talk about triangle sums and exterior angles. So let's get started with that. Excuse me. No, 3.4 has like 2 theorems in it. And I'm planning on talking about those 2 real quick on Friday, or excuse me, on Monday, when we go back to how 2 parallel lines are cut by transversal. When we go back to review all of those things, I'm going to give you these 2 theorems, which are going to be like, oh, well, yeah, duh. And there's no reason for me to waste a whole day on those things, because it's like 6 minutes. So that's why I like to bring it in with the review stuff. So when we're looking at these things, normally, I should say normally, I would wager to guess that I would say about 90% of you guys know how many degrees are inside of a triangle. Yes, sir. 180, very good. So the sum of the interior, what we say here is, the sum of the measures of the interior angles in a triangle is 180 degrees. And I'm pretty sure each and every single one of you guys knew that. Am I editing that bad today? I've only worked like 1 day or half a day this week, so it's kind of hard. I'm out of practice. The sum of the measures, the interior angles of a triangle is always going to be 180 degrees. Unless you're on a spherical plane, but don't worry about that. What? What? What's a sphere? 3-dimensional circle, okay. So, if I have a sphere, it looks like this, right? When I look at a sphere, you think of it in terms of a globe, right? Yeah. Now, the globe has an equator, right? And then the longitudes go downward, correct? Now, aren't all longitudes perpendicular to the equator? Wouldn't they be? Now, what happens if you have a longitude that goes up to the North Pole and hits another longitude, goes back down to the equator, and it's got a right angle there? Because that happens, right? And then you have another right angle here. Well, isn't that a triangle? 3-sided? It's 3 sides, isn't it? But the triangle, don't lean in your chairs, please. The triangle here doesn't equal 180, does it? It's 270. How is that possible? But I have right angles. Because the curvature. Because the curvature of the sphere allows you to do that. So next time somebody says all triangles are only 180, you can say, I can bet you I know something. So, yeah. Yeah, you'd have to go. You have to come out. There's got to be a way. Actually, you know what? I don't know if you can. Now that you say that, I'm not sure if you can because the way the things, the way. Actually, yeah, you can. You just got to come across. You would come across all the way over, all the way around, and that would have to work because then you're cutting it into. Think of it cutting it into a fourth, and that would be a square. All those sides would be equidistant. That's a good question. I didn't think of that one. So, yep. There's your spherical geometry. One thing I learned from the Geometry 353. All right. Sum of the measure of the interior angles is always going to be 180 degrees. And for our lives, that will never change unless you take Geometry 353. Also, triangles, if they have interior angles, they also have exterior angles. So here's your interior angle, here's your exterior angle. interior, exterior, interior, exterior. What do you think an exterior angle talks about? Outside. It's an angle on the outside. Okay. Now, excuse me. Exterior are angles Now look at the relationship between interior and exterior. What is something that you may or may not be able, I should say, you should be able to decipher via the diagram? What? Whatever. Sir? I can give you a counterexample of that. Now my exterior angle is acute, my interior is obtuse. I'm looking for a general statement here. What is something you can say about the relationship between interior and exterior? No. 180 degrees. Some of the interior and the exterior will always be 180. Because look what happens. Look at it. Are they all right? Those two always create a line, don't they? Those two will always create a line. These two always create a line. And look at that. Those always create a line. Which means the relationship that happens between interior and exterior angles is that interior and exterior are supplementary. Means they will always add up to equal 180 degrees. Okay. Always, always, always. Excuse me. Can you have interior and exterior angles on any polygon? Yeah. Yep. And that's something we talk about. I'll show you an example out here in a little bit. Now, one of the things that happens here when you're talking about interior and exterior, if I go back to this example here, if this is 100 degrees on the inside, that makes my exterior angle how much? 80, okay? How many degrees are total on the inside of a triangle? 180. So, if there are three angles inside of a triangle, and I know that one of them is already 100, what do these two here have to add up to equal? 80. Does it say that they have to both be 40? No. Could they be? Yeah. If they were, what would be marked in the diagram? Yeah, there'd be little tick marks, or it could be marked as, remember this thing, an isosceles triangle? Oh, yeah. If you have congruent legs, you get congruent angles. If you have congruent angles, you got congruent legs. It's one of those little things. So these two would have to add up to equal, oh, look at that, 80. Convenient. All right. What's the supplement to that? 78, okay. What's 78, 62, and 40? Huh. What's 62 and 40? Huh. Like, what? What is this sorcery? Okay. So if I have 130 degrees, 50 degrees for interior exterior, give Give you another angle. How many degrees are in a triangle? 180, all right. What's left of that bottom right? 82? What's 82 and 48?
That's only like 1205. Never gets old. Yes. Thanks for keeping up with us. So, the exterior angle, so do
This exterior angle to 50 is 130. You okay with that?
Yes.
What's exterior to 82? 98, okay. What's 50 and 48?
98.
Huh. Is there a pattern? I wonder. Okay, what's the, move this over a bit. What's the exterior to 48? 132, huh? Which so happens to be the sum of what? Whoa! She's like, wait, what? Which? Here's what happens. The measure of any exterior angle always equals the sum, which means the addition of the two angles it does not touch. Again, real easy example. There's my exterior angle. It touches its interior, which means it doesn't touch the other two. The exterior angle will always equal the sum of the two angles it does not touch. Always, always, always. Okay. Now, this whole idea of interior, exterior angles, triangle sums, and things like that, we use it all the time in geometry. We use it so much. For example, and you don't have to draw this out right yet. We're going to worry about this here in about a month or so. But if I'm looking at you may or may not have done this before. If I have a square, how many triangles can I draw inside of a square that do not overlap? 2. That's not a lot. That's just 2. Now, inside of a square, you can have what are called 2 non-overlapping triangles. Well, how many degrees are inside this triangle? How many degrees are in that one? Which means how many degrees are inside of a square? Okay? Pentagon has 5 sides. I can draw 1, 2, 3 triangles, which means I can have 3 times 180 degrees. Okay? The hexagon, I have 4 of them. 4 times 360. And so on and so forth. Now, in each of these shapes here real quick, if I have 4 sides, how many exterior angles do I have? There's 4 of them. In a square, what do each of the interior angles measure?
90.
Which makes all the exterior 90, okay. So these are all 90. How many degrees are there to get around a square? 360, okay. In a pentagon, you've got 1, 2, 3, 4, 5. Which means you basically have to get all the way around something. How many degrees does it take you to get around a pentagon? 60. How many degrees do you think it's going to take you to get around a hexagon? How many degrees do you think it would take you to get around a heptagon or a septagon? And so on and so on. Which basically is getting to the point of what will all the measures of the outside angles always equal? 360. Doesn't matter. The interiors will always be different, the exteriors never change. Yes, sir? You get 6 of them. How many sides are there in an octagon? What's 8 minus 2? Because here you got 7 sides, you got 5. 6 sides, you got 4. It's all. Gee, who would have thought math was pattern recognition, right? This is kind of where the reason why we start with, guys, the reason why we start with this whole idea of this triangle sum, talking about interior angles, talking about exterior angles, is because eventually we'll be able to do more complex things like this. And these things are, it all starts with 180 degrees, right? It all starts with that. I'll show you an example. What we're going to want to do, though, is find measures of angles. Take a second. Figure this one out. All right. Take a second. Redraw it. Now, this one's a little weird. Here's how I would draw it. I would just go up, down, over. Well, pick the like one line and just go like that. This is why I never took an art class. I should have. Maybe if I do it this way. Down, up, down, up. Oh yeah, like that. That's easier. Take a minute to figure those out, okay? Please and thank you. And then we'll start with the 45 and the 65. All right, what do you get? 110. Then that means what's angle 1? So you have a 70 there. Now, what do all 3 of these have to add up to equal? Okay, well, what's 70 and 45 leaves you 65. Gee, isn't it convenient when they give you the same numbers? Which gives you how much for angle 3? 75? These two are going to be 85. Then,
95.
see where I was going with that? I knew what you were doing. You were thinking, you were subtracting real quick instead of adding things together. All right, right off the top, I think. Okay. Super quick, guys, super quick. Will it change if I throw algebra into it? Nope. Ladies and gentlemen, I still have a couple more to go here. If I'm looking at the sum of the interior angles always adds up to equal how much? 180, right? That's all it is, man. Remember, the math isn't going to change at all when we start that in terms of algebra. The process of everything gets started is always going to be the same. In this case here, with the sum of the interior. So, 2x plus 3x plus 55 has to be everybody okay with me skipping a couple of steps?
Yeah.
Remember, all I did there was I just moved the 55, combined the 2 and the 3 right off the bat. Right. Now, same deal, bless you. Same thing's going to go for when we work with exterior angles.
Well, I'm not supposed to do that, right?
The same thing's going to happen when I start looking at the exterior, guys. Is it going to change anything? Nope, that's going to look ugly. Start again. Is anything going to change here when you have an exterior angle?
Oh.
So, in this case, we have the exterior angles 4x plus 8. The two angles that it does not touch would be, what, 2x plus 3 and a 51? Which means that algebraically, the sum of the, the exterior angle is going to equal the sum of the two it doesn't touch. It's not any different with numerical things. You just solve for x. Exterior angle equals the sum of the two it does not touch. Excuse me. Again, combine like terms on the one side. We get 4x plus 8 is 2x 54. Excuse me. All right. Now what do? Subtract 2x over to the left. I'm going to subtract the 8 at the same time. I get 2x is, what is that, 46, which gives you x of 23. The process by which all of these things work does not change at all, guys. Everything works out to be the same. Everything sets up the same. It's just a matter of excuse me, looking at the specific diagram and going from there. Okay, what you looking for? I don't have any. So, I don't think I posted it yet. I forgot, because I forgot what page it was. Homework-wise, I had stuff for you. Actually, I think I had the same comment. No. Did not save it. Oh well. This is section 3.5. And if you give me a second here, before we run out of too much time, I'd like to show you how to start up an ugly one like number 31. And I mean, it's hard, but there's a lot of stuff going on. So it's a matter of where do you start the problem, okay? So write that up for a second here while I pull it up on the smartboard, and I will show you what 31 looks like and how to start it, okay? What page was it? 1 second. Okay.
Always wanted to. Yeah. That.